Does this graph represent a linear function? To help us answer that question, let's go ahead and recall what we know about the graphs of linear functions. Let's take a look at an example of a graph that is a linear function and a graph that is a nonlinear function. That way we can better tell the difference. So let's say we have this graph right here. Taking a look, this graph looks like it's a straight line. Remember, linear functions are straight lines. But to be absolutely certain that this is a linear function, we need to take a closer look at the changes in the x and y values. So let's see. Here we can see that as our x values are increasing, our y values are decreasing. As we increase x by 1, our y values are decreasing at a constant amount each time. So, both x and y have constant rates of change. As we change x the same amount each time, y is changing the same amount each time. So, since we have those constant rates of change, that means that yes, this is a linear function. Those constant rates of change create this straight line. Perfect. Now let's go ahead and take a look at a different graph. Let's say that we have a graph that looks something like this. Well, for starters, this graph does not look like a straight line. It looks like we have a big curve right here. But to be sure, take a closer look at the changes in the x and y values. Here we can see that as we move from left to right, our y values are decreasing here, but then they start increasing over here. Well, having y changing from increasing to decreasing, or decreasing to increasing, is a sign that you do not have a linear function. Here we can see that as we would change x by a constant amount each time, our y values would change by a different amount each time. So those y values do not have a constant rate of change. Since we do not have a constant rate of change, that means that this is not a linear function. This is a nonlinear function. And nonlinear functions, because they do not have that constant rate of change, tend to have curves or jumps or something like that in the graph. So now that we have a better idea about the graphs of linear functions, let's go ahead and take a look back at the graph we were given. Does this graph represent a linear function? Well, if we look, it does look like it's a straight line. So that's a good sign. But we need to take a closer look at the changes in the x and y values. Here we can see as x is increasing, y is increasing too. That's a good sign. Y is increasing the entire time, unlike with this nonlinear graph where it was decreasing and then increasing. Here we can see that as we would change x by a constant amount, our y values are changing by a constant amount as well. That means we have those constant rates of change. Since we have that, we have the makings of a linear function. So now we know this graph is a straight line and represents a linear function.